Okay, so now after that, we'll discuss about the intercept. Of course, the intercept will give us the y-intercept value, okay, of our model. Then the slope now. This function slope will calculate the slope, or it will back calculate the what? The slope of that is regression line. Okay. Basically, behind the scene, it will make calculations, that is change in y divide by what? Change in x. Okay. That is in order to get the slope. Okay. The formula it's already programmed in what? In this function. And then we'll also have another new function which is called linset. Okay, or linst. Okay, if I that is its that is linst. Let me just call it that way. Linst is a function. It uses least square methods, okay, or least squares regression method, okay, to calculate both slope and that is intercept. So basically, this function will give us or will return that is a value on the slope, okay, and a value on what? On the intercept, okay. It will give us the value for slope and a value for intercept. Okay. Okay, good. Let's continue. So we are going to start with that is the lines function, and of course it will give us now the option to enter what? To enter our that is our y's, our y's and x's. Okay. Yes, or we'll get that is the formula will give us now that is a guideline. Okay, it will give us a guideline on how to do what? To get the value of the what? Of the slope and the what? And the intercept. Okay, so we are saying that because the that is length function returns an array of values, you must enter it as what? As array formula. Okay, we shall see that. So you can see this is the formula and our possible what? Our possible output. So it will give us the output for the slope and output for what? For the y-intercept. Okay. Then, of course, you can also try now to break down the what? That is the equation or the model, okay, into parts and calculate, okay, each constant, okay, separately, okay. Like for example, we know this is slope, okay. So in this case, the other method is to use what? The slope function to determine the what? The value of the slope, okay, which is the variable attached to x, okay. You can also use intercept function, okay. You can also use intercept function to calculate what? To calculate the intercept of what? Of your model. Okay. Basically, it's how we are going to that is use Excel inbuilt function to calculate what? To calculate the slope and the intercept. Okay. Then the last thing is now the correlation. Of course, we know correlation tries to indicate how strong or how to that is the strength of the strength between two variables. Okay, that is it tries to indicate how strong the two variables are related to each other. Okay, so with that, now we will be able to do what? To calculate all the variables, all the constants we need. Okay. Yes. So now we are going to deep dive to now to the practical part of it. Okay, and see how we can calculate this and maybe build a model that is a model. Okay, out of these two values. Okay. Good. As that is for our last class. Remember, we calculated our model using that is our coefficients using analysis toolpath. So you can see this is what these are our coefficients. Let's try and see if we are going to get the same coefficients. Okay, using now that is the variable attached to x, and also, that is constant attached to a variable x, and also our y-intercept. Okay, so in this case I'm going to enlarge this. Okay, and then I will start with the first formula, that is length. Okay, and we've said this function will give us what? It will give us slope and what? And the intercept. Okay, so this is what? This is our first formula. Okay, this is our first formula. Okay, so let's try and see that is how, or the output will get. So it will be equal to that is length, and you can see it returns statistics that describe a linear thread. Okay, matching known data points, and by fitting a straight line using the least square method. Okay, so in this case will be needed to highlight that is the array of all the values of our that is y non-y's, and also values of what? Of x nons. Okay, that's all what we need. Okay, so in this case you are going to highlight. We'll start with our non-y's. We know the umbrella cells is what? They are that is set of our non that is y's. Then we have non-x's. Okay, so we have our non-x's. So we are going to highlight the that is the what? The array of the data points on the rainfall amount. Okay, so after that now you can that is run. Okay, if you enter, for my case I've gotten only one value because of
I please come up again on that formula, please.
okay, good. So I will repeat on the formula. So for that you'll use line set. Okay, that is lines. I don't know why I'm using the other name. So lines. Okay, then you will need what? Non-wise. We need non-wise. So you will highlight all the what? The range of the of the y values. Then do a comma. Of course, it is showing us a comma after highlighting the non-y's, of course, then non-x's. Then after now, you have to highlight what? The non-x's, which is what? Which is the rainfall amount. And then that is you close your bracket and then enter. Okay. For those who are using that is Excel function or Excel version. Okay, that is latest Excel function. You will see version, sorry, you will see what? You will see two variables, all you see two output. Okay, unfortunately in this that is a laptop, I don't have the most updated that is uh, Excel. Okay, so that's why it is giving me only one value, but it should give you two values. That is the what? The slope and the what? And the y-intercept. Okay, someone can confirm that. Elizabeth, I guess you are using that is Excel 365. What value have you gotten?
Hi, I've not been able to. I was more keen. I've not today. I've not done the practical.
Okay,
Yeah.
but you have the data set already.
Yes, I do, but I
Can
think I'll do later because I'm trying to. Was trying to follow up on what we are doing.
okay, maybe can you try to write this? You can open the file and try to that is, use this formula and see if we can do what? If you are getting two values.
Okay, sure.
Okay. Are you in a position maybe to share your screen so that the others might see? Hello, Elizabeth.
Yes, yes. Let me try. I'm
Yeah.
doing that right now.
Okay, you can share your screen so that you may. I will just guide you. I will guide you so that you may see that is the output which we will expect, or which we are expecting to get. Okay, good. Now can you
So,
okay, you can just copy the that is the data set into a new worksheet.
yes.
Okay, I can see Mani Alfred have gotten two values. Nice, nice. Can you also confirm if they are the values which we got while using the other, that is, while
Yeah,
using the other?
this is what I'm getting.
Hmm. I can't
Is
see,
this
I don't know if it's my screen, but I can't see your screen. Maybe you are sharing the wrong screen.
oh. Is it clear now? Are
And
you able to see okay.
no, not yet. Or
Okay.
anyone
Let
else
me
who can see? For my case, I can only see.
Um,
Okay,
I have this. Maybe I think I've gotten the right screen.
okay, you can share now. You can
Is
reshare your screen. Yes, you've gotten two values. Okay, so basically that's
yes,
how
yes.
the that is the output will look like. Okay, so in this case, you can see you have the slope and you have the what? The y-intercept. Okay, yes, so that's the slope and the y-intercept. I just wanted you to confirm that is for sure we are getting to values. Okay. Okay, good. Now let's continue to the second, that is Excel function, that is B. Now, B, it's that is the second function, will be now computing slope, okay, and what? And intercept, okay, computing slope and intercept. So for these two, you are going to that is to use the two separate functions, that is for slope and also for the intercept. Okay, so with this we are now going to use the slope function. We have a function by that is called slope, and you can see, sorry, we have a function called slope, and that is slope. So slope basically returns the slope of a linear regression line through the given what data point. So we are going to calculate the slope, and for slope, of course, we will also need two arrays, that is the non y's and the non what, the non x's. So we are going to highlight the non y's, okay, comma, the non x's, okay, and then done. If you run that, you are going to get the what, the value which we've gotten with what, length function. Okay, then The other function now, it's the intercept. We also have intercept function, okay? And for the intercept function, calculate the points at which a line will intersect the y-axis by using a best fit regression line plotted through the plotted through the known x values and y values. So intercept, it will give us now the what, the point where the line, the best line, all the, yeah, will cut, all the regression line will cut what, will cut the y axis. Okay, so in this case, for intercept, we'll also need known y's and known what, x's. So with that, we are going to highlight the known y's, okay, comma, and then known x's, okay, and then after that, you'll get now the what, the y-intercept. Okay, so basically at the end we'll create a model which looks like this. That is y is equals to what is the value, that is 0.4482, okay, will be 0.4482, okay, x multiply by, let me just write a better x, this is 2 x, okay, plus what, plus or minus our intercept. So that is our intercept. So in this case it will be minus 18 point, that is 915, and this will be what, this will be our model, because you now given future values of x, okay, given future values of f, we can do what, we can now calculate, that is, we can now predict what, our y. Okay, yes, so basically that's all on the, that is the regression using Excel formulas, okay, as well as regression, that is using what, that is regression analysis. Okay, that's all about the topic regression analysis. Of course, I'm going to share, that is real world, that is example, or not real world example, real world exercise. Okay, I'll give you an exercise on regression analysis. Okay, so of course you can try your best where maybe you've not gotten it right. You can reference to our, that is our videos. As well, you can do what, as well, you can also research more in case maybe you get what, you get any that is difficult or part. Okay, yes, otherwise I'm also here to guide you. So now the good thing is, please make sure you remember this what, this regression knowledge. Okay, this regression knowledge is very important, because here for us we are now using Excel to compute this. Okay, when you will be dealing with machine learning, I know the first project or the first practical to do, it will be creating this model in what, in Python, or using Python programming. Okay, this is the maybe the, that is the, it, in fact it will be the first model to create, that is under unsupervised machine learning. Okay, to create a predictive model, you will find yourself calculating the, that is the uh, the coefficient of x variable, and also the intercept coefficient. Okay, the difference is that now the data which you are using, it will divide, it will be divided into two. Okay, either 80 part of the, that is 80% of the data will be used to train the model, meaning 20% will be what? To test what? To test the model that is making now some predictions. Okay, so this is the only different part, all the new thing you will come to learn. Okay, but the same process. You have to calculate the coefficients, you have to calculate the intercept. Okay, then now the different thing is that now you have to train your algorithm and also test it. Okay, yes, and that's all about regression analysis. I will share that is some exercises for you to do on that is a regression analysis. Okay, all right, are we good up to that point? All good? If we are good, maybe by a show of hands. Okay, our
Hello.
yes, Donald.
Can you share the recording for Thursday
Okay, all right, I will share.
and the one for today?
Okay, okay, I will share maybe after, I will share after this class. Okay, okay, good. Now let's introduce another topic. Okay, a new topic, that is distributions. Okay, so basically under distributions, I know of course it's a new, I don't know if it's a new, but to some people this might be a new term. Okay, but and when we are talking about distribution, we are just trying to talk also about probabilities. Okay, like how maybe we can describe the likelihood of a certain event to do what? To occur. Okay, someone has raised hand. Okay, and kindly send the notes on PDF. I guess I shared these notes. Please confirm with your email, Rebecca. I shared that is via email. Okay, good. Let's continue. So basically, under product, that is a distribution, we'll talk about, of course, we'll be talking more of a probability distribution. Okay, but we are trying to see how we can model, okay, different probabilities or different that is likelihood, okay, of that is of a value or of an event, okay, happening. Okay, so in this case we'll see that is factors which might affect the that is the probability distribution. Maybe it can be mean is what is affecting, it can be standard deviation is what is affecting, it can be skewness and kurtosis, which is what, which is affecting our distribution. Okay, also we'll talk about that is skewness, and we'll also talk about what, kurtosis. Okay, we'll also talk about those two. Remember that during our that is our descriptive statistics, there is one measure which we did not cover, that was measures of asymmetry. Okay, now under measures of asymmetry, it's where now we learn about skewness and what, and kurtosis. Okay, then after that we'll also try to check the different types of probability distributions, and in this case we are going to measure that is, or we are going to discuss only the measure what, types of distribution. Of course, we have very many distributions. Okay, we have independent distributions, we have also mixtures. Mixtures, they are kind of distributions which combine two different distributions. Like I can remember that was my project back in that is college. I was trying to use mixtures, that is combination of two distributions, okay, to what? To measure or to determine that is the amount of reserve, okay, needed, or the amount of capital needed to be reserved, okay, in what? In an insurance. Of course, I was modeling claims, okay, and trying to see like what percentage of the that is of the reserve can I make, okay, what percentage I can keep for compensation of claims if they are reported, and also a percentage of investing, okay. So with that, we know even if we invest, okay, even if we invest, we have an enough reserve, okay, to do what? To cover given number of what? Given number of claims, okay. So with that, I used inverse Gaussian, that is Gaussian inverse Poisson Gaussian distribution. Yes, kind of. That is, it was a mixture of that is inverse or inverse of Poisson distribution, okay, and normal distribution. That is the inverse. That is Gaussian Poisson distribution. Okay. All right. So majorly we will discuss for, but for this lesson we'll only discuss about, let me just open new workbook or work area. So in this case we are going to discuss about normal distribution. Normal distribution. Secondly, we'll discuss about binomial binomial distribution. We'll also discuss about Bernoulli distribution. This is a special case of what? It's a special case of binomial distribution. Okay, so we shall also cover that, and then we shall cover Poisson distribution. Poisson distribution. So these are the major three, four distribution we'll discuss. Okay, and then I will give you exponential distribution as what? As your exercise to do what? To research on. Okay. Also, before I can start this topic, please go and research, that is different applications of regression analysis. Where can we apply regression application of linear regression analysis? Okay, and also check on multiple linear regression. You can go and check on these two. Application of linear regression in real life. How can you apply linear regression in what? In your workplace, okay? And also maybe you can try to explore, that is explore more on the multiple linear regression. Okay, so in this case, we'll discuss about normal distribution, binomial distribution, Bernoulli, and Poisson distribution. Okay, these you will find that they are discrete distributions. Okay, they are discrete distribution. This is continuous distribution. Okay, meaning here we are talking about number of events happening. Okay, like for example, for Poisson, it is discrete, is also known as count distribution. Okay, and it will involve you okay, or it will involve that is a count of what, of events. Of course we cannot have 3.2 events, okay. It's either 1, 2, 3, 5, 20 events occurring, okay. And also in Poisson we have now the aspect of what, of period or of time, okay. So in this case you'll be able to see like what is the probability of maybe two events occurring within what, 1 hour, okay. Like also for example, if you work in that is in pizza outlet, okay. And you know, like let's assume every what, every Friday you usually sell around 200 pizzas, okay. So we can calculate that what is the probability that next Friday you will sell maybe more than 300 300 pizzas, okay, or you will sell double of what you usually sell, okay. So basically you can see we are in that, even if we are calculating probability, we are using like discrete values, like whole values. Like when I talk about pizza, I'm talking about number of pizza, okay, full pizzas, not 2.5, not 1.2, not 1.5, okay. So we are talking about a whole number, okay. Then when we be talking about binomial distribution, we'll be talking about major that is majorly output, okay, like two output or two results at the end. Like for example, it is a win or a lose. It can be a head or a tail, okay. It can be a yes or a no. So for binomial, always have two possible outcomes, okay. Here we'll be talking about two possible outcome. It's either a yes or a no, or it's either a win or a loss. Like for example, if you go to maybe to like let's say a football game, okay. Of course, we know we usually have two possible outcome. It's either you lose the game, but that one now comes, it has added another outcome because you might draw. Now, let me give you an example. Like for example, let's assume you are a basket ball person, okay, or you play basketball, okay, and you are on the what, is it called the pitch, or the that is this is the pitch, and you want to try, okay, the number of times, okay, you will make a ball through what, through the basket, okay. So if you make the ball through the basket, we can try and record it as one representing a win. We can say it is one representing what, a win. Or if you fail to take the ball through it, that is the basket, then it will be what, zero. Zero meaning it's what, it's a loss, okay, it is a loss, okay. So in this case we are only dealing with what, two possible outcomes. It's like also when maybe we are flipping maybe or tossing a coin, okay. What do we expect? We expect only two possible outcomes, okay. That is a tail or a head. So basically binomial distribution will take that is that route. Of course we'll talk about more assumptions which we make under binomial distribution, because we usually assume that is each trial is dependent to which that is to the other, meaning that is the first occurrence or the first output or outcome does not affect the what, the second outcome, okay. All right. Then we'll talk about binary. So for binary, you'll find that it's a special case of binomial distribution. And here, whenever maybe we are dealing with n is equals to 1, like for binary, only takes one trial. Okay. And like in binomial, where it can take what? N trials. Okay. But for binary, only takes one trial. Okay, that's why we are saying it is a special case of what? Binomial distribution. But when it comes to the other assumptions, they are all the same. Good. Now we have that is our normal what? Our normal distribution. Okay. For our normal distribution here, we are talking about, we are saying it is a continuous. Yes, because like for example, it is used to model things like performance. More so, let's assume we are in a class here, we do a cut. Okay, so definitely will have different scores. There are those who will that is score 1, those who will score 0, those who will score 1.5, those who will score 92.2 or 92.5 scores. Okay, so you can see there when we talk about point, we are talking about now the issue of what? That is the issue of continuity. Okay, so we usually represent normal distribution in this format. Okay, so definitely we'll talk about normal distribution. Okay, which is continuous, and for the continuous distribution we usually use a curve to that is to represent it. Okay, but for Poisson binomial, okay, we'll use what? We'll use bar graphs. Okay, we'll use bar graphs to do what? To represent that that is that distribution. Okay, all right, and you'll find maybe at the same time it might look seem to look like that of normal distribution, but for this is what? It is discrete. Okay, okay, you can you'll see us presenting this in what? Using bar that is bar graphed. Why? Because it is a discrete distribution. Okay, this is just an example, but we shall see the output well when we'll be now doing it practically. Okay, good. Now, just to give you heads up, what you need to do, that is under distributions. Okay, under distribution, for you now to that is to work well and also to be able to that is to tackle that is your questions well and distributions. Okay, so what you need to focus on are the what? It's the properties properties of what? Properties of the distributions. Okay, and then the second is the application. Okay, of the distribution. For practical, you won't get any practical on distribution. You won't get like, for example, maybe you are told to calculate or to model or to present that is to graphically represent what? The application, because the practicals which you are going to use is maybe to solve a problem and also now using the data given to do what? To represent or to present that distribution in what? In graphical manner. Good. So let's continue. Now we'll start with the probability distribution. Okay. Of course, I've introduced most of the things. Okay. So let's start. That is our what? our class. So of course we'll go through the theory. We'll go through the theory part, okay, and then after that we'll go to what? We'll go to that is the practicals. We'll first handle the theory and then go to the practicals as we usually do. Good. So probability distribution. What is probability distribution? So basically, probability distribution is a statistical function because you will find that in each that is distribution, it has what? It has a function. Like for example, for normal distribution, okay, that is probability of x, that is for normal distribution, or function of x, okay, will be given by 1 divided by sigma, okay, which is the standard deviation, divided by square root of 2 pi, okay, multiply by exponent, okay, multiply by exponent into raised to negative half, okay, into x minus mu, okay, x minus mu divide by sigma, I guess so, squared. If I'm not wrong, or no, I don't think we have this. Or basically, it can be presented in this manner. It can be presented in this manner. That is into that is x minus mu divided by 2 squared. Maybe I have to confirm this. I have to confirm this. It's long time. This is for normal distribution. For normal distribution with mean mu and variance that is sigma squared. Okay. Then we have binomial. For binomial distribution, we know that that is the function of x will be given by n combine x, okay, multiplied by p, which is the probability of success, raised to x, okay, multiply by probability of what? Of not success, probability of not, or probability of failure, raised to n minus x. Yes, I can remember this well. So this is okay. Maybe we can confirm, we can try to confirm that is the formula for normal distribution. Normal distribution formula. Formula for normal distribution. Sorry, normal distribution. Yes, sorry, we had a sigma here. So my first formula was correct. So like we can say now, multiply by 2q, or we can that is a 2 that is sigma, or we can now say multiply by that is raised to negative half into x minus mu divided by sigma squared. So this is the what? The formula for normal distribution. So when we'll be doing the practicals, we'll break down all this. Okay, we'll break all down all this into segments to calculate the probabilities mathematically, and then we'll also use Excel functions, okay, to calculate the same. Okay, we'll also work on that is Poisson distribution with the function, with its function the same as that is a exponent of negative lambda, okay, multiply by lambda raised to x, okay, divide by x factorial. We shall all discuss all this, okay. We shall all that is break down to all this to check what is lambda. In this case it will be our mean. What will be x of course will be our number of events. All this, okay, we'll break them down during that is our practicals. Good. So probability distribution, that is there, all is a statistical function. Okay, statistical function. This is what I've shown you. These are the statistical functions. These are the statistical functions. You can see function of x, which is following Poisson distribution, function of x, which is following a binomial distribution, function of x, which is using following what? A normal distribution. Okay, so a probability distribution is a statistical function that describes all the possible values and likelihood that a random variable can take within what? Within a given range. Okay, so here we are trying to come up or to check the likelihood that a random variable will take, okay, within a given range. Okay, so this range is bounded by what? By minimum and maximum possible value. Okay, it is bounded by minimum or that is by minimum and maximum value. Like for example, for the normal distribution, okay, that's why we usually use integration. So we can get any value between what? Between 0 and 1. Okay, yes. So that is for normal or for that is a continuous distribution, sorry, normal distribution. Okay, then bounded maximum between minimum and maximum possible values, but precisely where the possible value is likely to be plotted on the probability distribution depends on the number of factors, and these factors might include the mean, of course, the mean of the what? Of the data. Why am I saying so? Okay, for a normal distribution, we know that for a perfect normal distribution, okay, all the what? All the tails are the same, okay, in terms of thickness and also thinness, okay. But what if maybe your data is skewed to one side, okay, or skewed to another side? Will that be still a normal distribution? Yes, of course, it will assume a normal distribution, but okay, it will be what? It will be that is it will be skewed, okay, or it won't have the same shape as what? The standard normal distribution. So in this case, it might be affected by maybe that is mean, okay? It might be affected by mean, it might be affected by standard deviation, it might be affected by skewness, okay? And it might be affected by what? By kurtosis, okay? Good. So we have types of probability distribution. Okay. Of course, we have normal distribution. We have chi-square distribution. We have binomial distribution. We have Poisson distribution and many other distributions. Okay. All right. So we shall discuss each distribution one by one. Okay, so basically to wrap this up, we can say that a probability distribution depicts the expected outcomes of possible values for a given data generating what? Generating process. Okay, so for probability distributions come in many shapes different characteristics as defined by mean, standard deviation, skewness, and kurtosis. So of course we have that is most of you I know distribution by what? By their shape, that is by their graphical representation. Okay, but that is distribution, it's more than what? Just a shape. Okay, you must be able to know a distribution maybe from its characteristics. Okay, from its that is the from its properties. Of course, properties and characteristics, they are the same thing. And also the impact. Okay, with changes in these factors, that is the mean, standard deviation, skewness, and kurtosis. Okay, so investors majorly use probability distributions to anticipate returns on assets. Okay, such as maybe stocks over what? Over a period of time. So of course they will be able to model different what? Different that is assets returns. Okay, and in this case we are going to start with normal distribution, our only, that is our major or our most common continuous distribution. It's our most common continuous distribution. Okay, so we are saying that in probability theory, okay, in probability theory, the normal distribution is also known as Gaussian distribution. Okay, it is also known as Gaussian distribution, or the bell what? The bell shape distribution. It's also known as the Gaussian or the bell-shaped distribution. Okay, so this is what? The bell-shaped distribution. Okay, it is the most significant continuous probability distribution. Sometimes is also known as, or it's also called as that is called a bell curve. Okay, or bell-shaped distribution. Okay, a bell curve or a bell-shaped distribution. Okay, you can see it looks like what? A bell. Okay, it looks like a bell. That's the reason why it is called that. Okay, so a large number of random variables are either nearly or exactly represented by what? By normal distribution. In every physical science and economics, in that is we are saying that like most of random variables are represented by normal distribution, more so in physical sciences and also economics. Furthermore, it can be used to approximate other probability distributions. Okay, therefore supporting the usage of the word normal as in about the one and mostly used. Okay, so of course the bell has some empirical rules. Okay, it has empirical rules, that is like approximately that is 67 of the data. Okay, falls within one standard deviation of the mean, between, that is between mean and one standard deviation. This is just like and that is a theorem or a rule. Okay, that is your data, or 68% of your data should fall that is within one standard deviation of the mean. Okay, maybe we can try and check what this means. There is a graph which usually empirical rule of normal distribution. It always that is states well. Okay, it always states well. Okay, so you can see what the empirical that is shows. Okay, so you can see like 68% of our data should be within one standard deviation, like should be within the mean. This is our mean. That's why you can see x bar here. Okay, so here we have x bar minus what? One standard deviation. Okay, so that is, you can see this area and this area, it is it takes the what, the first rule, that is we should have that is 68% of the data falling between these parts. Okay, then the second rule is 95% within two standard deviation. So like for example, the that is 95% of the data should be between what, between this part and what, and this part. That's why you can see it's plus or minus, because if these cuts may be the curve here at x-axis, then this will become now the negative part of the x-axis. This will become the positive side of x-axis. Okay, so basically we are saying that that is 95% of the data falls between what, between this part. Okay, and then the rest, that is the last row, it is what, it is 99.7 of the data should be what, should be fall, all should fall between what, between x bar minus 3 standard deviations, or it must fall within the what, the 3 standard deviations from what, from the mean. Okay, yeah, so basically this at least helps to understand, like the data it's within the mean, a little bit far away from the mean, and also to the tail far away from the what, that is 99%. Now if we were add this part, we can say like we are modeling 68% of the data. If we were using that is the data points between this part and this part, we would be saying we are using 95% of the data. And then if we are using the data between here and here, it will be 99.7%, meaning the 0.3, it is along that is the along what, along the tails. Okay, along the tails. Okay, good. So basically this what it was just a summary of what that is the empirical rule states. Okay, so we also have now the normal distribution properties. We have some properties for normal distribution. Okay, so we know that normal distribution for a standard, let me, because not all normal distribution are perfect distributions. Okay, not all normal distributions are what, are perfect distributions. That's why we are saying that for only that is standard normal distribution. Okay, for only standard normal distribution, okay, mean, median and mode are equal. For standard normal distribution, only that is sorry, for normal or for a standard normal distribution, the mean, the median and the mode are equal. This is the major that is property of normal distribution, of, in fact, of a standard or of a perfect normal distribution. You will find that the mean, the sorry, the mean, the median and the mode are what, are equal. And then the total area under the curve is equal to what, it is equal to 1. Like the total area, the total area under the curve, okay, the total area under the curve is equal to what? To 1, like the total probability. We know that probability ranges from what? From 0 to 1. So the total area of this should add up to what? 1. It cannot exceed 1. Okay? Then the normally distributed curve should be symmetric at the center. Okay, it should be symmetric at the center, meaning this is the normal distribution. For it to be symmetric at the center, it means that when we, like, it is possible to cut the normal distribution into two equal parts. Okay, meaning the area for this will be equal to area for this. Okay, and at this point, okay, at this point it will be equal to the what? To the mean of the what? Of the data. Okay, yes, so basically that's what we mean. So we are saying that the normally distributed curve should be symmetrical at the center. That should be exactly half of the equal, that is half of the values are on the right of the center, and exactly half of the other values are on the left side from the what? From the center. That's what we've said. Like the values here should be equal to values here. Okay, meaning this is cutting this, that is the distribution, that is into two equal parts. Okay, good. Okay, another property, the normal distribution should be defined by the mean and the standard deviation. Yes, that's why we usually say that that is a data follow, or we say that a data set is normally distributed with mean mu and the standard deviation sigma. Why? That's why we are saying that normal distribution is defined by mean and standard deviation, meaning these are the major two factors which affect what? Which affect that is normal distribution. We shall check. We shall check how during that is our practicals, how mean and standard deviation affect that is normal distribution. Like for example, we might assume this is a normal distribution. Okay, so this is the initial normal distribution with maybe mean, let's say mean of 60. Okay, what if we change adding that is standard deviation constant, meaning the standard deviation is not changing, but we are changing mean. Okay, we can either increase the mean or decrease the mean. Okay, so in case where we increase or we decrease the mean, the normal distribution, sorry, the normal distribution, okay, the normal distribution will what? Will shift to the what? It will shift to this side. Okay, meaning at here we might have a mean of what? A mean of 40. Okay, but when we increase the mean, okay, you will come to see that the normal distribution curve moves to the what? To the the left along the same axis, meaning at this point we'll what? We'll have maybe, let's say, that is a mean of 80. So what we can say that change in mean brings what? An horizontal change in what? In that is a normal distribution curve. Okay, meaning here we are adding standard deviation as a constant. But when we now add mean as a constant, that is as a constant, and we are varying maybe the that is the standard deviation. Okay, we are varying this, that is the standard deviation. Okay, we are varying the standard deviation. Then you'll come to see that that is the peaks, okay? The peaks of the normal distribution is what it is changing, okay? The peaks of the normal distribution is what is changing. We shall come to at least look at a more that is at a more better represented what diagram, okay? So you'll come to know that, like, um, change in standard deviation, odding mean constant, okay, it will bring what? Change in that is it will bring a change that is to the normal distribution in terms of maybe that is increasing the peak of the distribution or flattening the peak of the distribution. We shall come to see that well when we'll be dealing with the practicals. We'll be changing, okay? We'll be playing with these parameters and see what is happening, okay? All right, then the normal distribution curve must have only one peak. So for normal distribution, it should be what? It should be having only one peak. Like, we should only have one peak, but not many peaks, okay? It should be only one peak. The curve approaches the x-axis but never touches, and it extends further away from the what? From the mean. So in this case, you can see this tail does not touch the what? The x-axis, okay? These tails, they don't touch the x-axis. They may appear to touch, they may appear to touch, they may appear to touch the x-axis, but they don't touch the what? They don't touch the that is the x-axis. They might appear to touch, but they cannot, or they should not touch the what? The axis, okay? That is the x-axis. All right, yeah, that's all about the properties for normal distribution, okay? Maybe the last part is like a normal distribution is a proper term for probability bell curve. In a normal distribution, the mean is zero. This is another factor. Like for a standard normal distribution, the mean is zero. That is for a standard normal distribution. We shall see how we can standardize a normal distribution, okay? And it should have, that is a mean of zero, a standard deviation of one, as that is a skewness of zero, okay, and a kurtosis of what? Of 3, okay? So basically this is another property of a standard normal distribution or a perfect normal distribution. It should be normally distributed with mean 0 and standard deviation 1, okay? Normal distribution are symmetrical, but not all symmetrical distributions are normal distributions, okay? So normal distributions, they are symmetrical, but not all symmetrical distributions are normal, okay? In reality, most pricing distribution are not perfectly distributed, and we have some applications, of course, for that is for normal distribution. Like that is, we can model that is the marks scored on a test. Of course, we'll have a few guys who will score that is above the average. We'll be having that is most of the students who are average, okay, and also we'll have some a few students who will be low performers, okay. So basically we'll have top performers, then have majority of that is majority of average performance, and also we'll have a list of what? Few let's say bottom or low performers, okay. Also, height over different persons. Of course, we say that is an example. Blood pressure. Maybe if you go in an hospital and try to model the what? Try to model the blood pressure data. Okay. All right. So, and then the last thing is size of objects produced by a machine. So these are just some of applications of normal distribution. We shall see more applications, and we'll take one application and do what and use it to do our practical. Okay. All right. So I guess that's all for today's class. I guess we are all together up to that point. By show of hand, if we are all together. Oh, nice. I can only see five. Let me say more. Okay. All right. Can see we are good. Okay, good. So, thank you for your time. I beg to stop at that end, then till we meet tomorrow. Okay, till we meet tomorrow for our next class.